This is the second video in a series about solving log and exponential equations. When we can't solve a log equation or an exponential equation because that works out nicely and we know the powers and things, we might need to rewrite it in order to use the one-to-one property or the inverse property, or we might need to take the natural log of both sides or the log of both sides in order to solve it algebraically. So again, I'm going to work through these examples as you need them. I would encourage you to try them on your own first and then check your answers here. So if we start with A, in this case, I have something raised to an exponent, and in order to solve it, I need to get the x out of the exponent. So I'm going to use the inverse property in order to undo that exponent. And what that means is that I'm going to take the log of both sides with the same base that is provided. So I'm going to take the log base 2 of both sides of the equation. So log base 2 of 2 to the x equals log base 2 of 7. Recall, our rules mean this x would come down front, and then we would have log base 2 of 2. This is equal to 1. So we just get x equals log base 2 of 7. This is the exact answer. The problem is done. If you need a rounded answer, which these directions say that you do, you would use your CAS, and you would enter the values. You would go to control, log. Luckily, your CAS allows you to just put in the base that you need, so you don't have to deal with a base change formula. So we put in 2 as our base, 7 is what we are taking the log of, and we hit control enter to get the rounded answer, and you get 2.80735. However, we want the rounded to 3 decimal places, so we would include 2.807. So 2.807 is our rounded solution. Moving downward, if I go to B, I'm going to start by simplifying as much as I can. So I'm going to divide by 5 on both sides. I now get 3 to the x equals 13. Again, I have an exponent that is the variable, and I need to get the exponent out of the variable, I need to get the variable out of the exponent in order to solve it. So I'm going to take the log of both sides. In this case, the base is going to be 3 because the base here was 3. So I take log base 3 of 3 to the x equals log base 3 of 13. Because of the inverse property, the expression on the left just equals x. And on the right, we get log base 3 of 13. That is our exact answer. If we then go to our CAS and plug it in, we get a rounded answer of 2.335. For example C, we have, again, the variable is part of the exponent. So because of that, we need to get the variable out of the exponent. How do you get the variable out of the exponent? You take the log of both sides. We're going to take log base 4 because 4 is our base. So if we take log base 4 of 4 to the x plus 2, that's going to equal log base 4 of 14. Because of the inverse property, this expression on the left is just the exponent, x plus 2 equals log base 4 of 14. In order to solve it for our exact answer, we just subtract 2 from both sides. So you have log base 4 of 14 plus 2. That would be the exact answer. If you want the rounded answer, go to your CAS, type it in, and you get negative 0.096. That's rounded to 3 decimal places. Finally, again, you have to do the inverse property in order to get the x out of the exponent. in order to get the variable out of the exponent. So I'm going to take the log base 6 this time. Log base 6. 6 to the 2x minus 1 equals log base 6 of 45. So we just get 2x minus 1 equals log base 6 of 45, which, by the way, if you just go to this next form, that's fine. You don't have to write the form up here where you write log base 6, but I always do it just because it helps me remember what I'm doing. So I see actually that I took the log of both sides. Then I'm going to add 1 to both sides, and then I'm going to divide by 2 on both sides. So I get an exact answer of log base 6 of 45 divided by 2 plus 1 also divided by 2, or plus 1/2. You could also just leave it as one big fraction, that's fine. This is the exact answer when you go to your CAS to plug it in. When you go to your TI Inspire, you should get 0.562 as your rounded answer.